Hello, I'm Paul Beckwith with the University of Ottawa Laboratory for Paleoclimatology. Recently, in Canada, a climate atlas was just released. It's based on something called the Prairie Climate Atlas. There's also climate atlases in the US. You can Google it. Also in Europe, for example. So wherever you go, hopefully places have these atlases, and if they don't, they should be developed because they're very, very useful. I haven't checked for China and India and some of these other places. But let me talk about what you can find out about where you live or any location in your country. So let me get started here. Go back to the computer monitor. And just lock it here. Okay, so if you just Google Climate Atlas of Canada, okay, or it's climateatlas.ca, then this is what you find, okay? There's lots of information about climate change in different cities and climate science, what you can do to take action to deal with climate change, and there's other sections which are a work in progress. So let's get right into the maps here. If you go Menu and Maps, then here's what you get basically. Okay, so you get a map of Canada, and you can pick different locations, and you can look at various parameters and see what's going on here. So I'm just going to click on Ottawa as an example, and there's two different scenarios, a less scenario and a more scenario. Okay, if you click on information here, so this is the more climate change is business as usual. It follows the Intergovernmental Panel on Climate Change Representative Concentration Pathway 8.5. The low carbon scenario follows the 4.5 scenario. Okay, there's a bunch of computer models that are generating this information. You can zoom in to different areas and motor around on the screen, do whatever you want. So let's have a look at, so what are we looking at here? There's a graph here which shows, so it's the projected change in the mean number of plus 30 degrees Celsius days. So in this 30-year time period, 1976 to 2005, which is the baseline. Now, I would choose an earlier, I think this would be better if you could choose an earlier baseline, because lots of climate change has already happened within this time period. But this is the baseline that they have here, and what it's showing is that going out to, this is 2051 to 28, we're increasing the number of days that are 30 degrees Celsius plus goes from 9.6 to 49, up 39.4 days, and this shows a graph from 1950 to about 2100, I guess, and you can see the increase of days that are, a significant increase of days. And to get information on this, what it means on the data, if you just click information, so this is very hot days, plus 30. Temperature rises to at least plus 30. And it gives you information about, it talks about why high temperatures are important for plants and animals to thrive. You can't be too hot. It could limit or so temperatures can limit or enable outdoor activities, and also it gives some information here about, especially when temperatures are very hot, the elderly and the very young are more susceptible to heat exhaustion and heat stroke. So, so let's have a look at some of the other parameters. So this is hot weather, very hot days. There's also, we could look at tropical nights, for example. So tropical nights, this is going from 2.6 nights to 26.5 nights. In this time range, 2021 to 2050, 9.8 nights. Okay, so it tells you the increase, and if you want to see how they're defined, a tropical night is when the lowest temperature of the day does not go below 20 degrees Celsius. Okay, let's have a look at the warmest maximum temperature. Okay, so you can see the change in the average warmest maximum temperature, 33.1 degrees Celsius up to 37.7 degrees Celsius, an increase of plus 4.6 degrees Celsius. And what you could do is we're looking in Ottawa, if we come up here, for example, you can see, you can have some effects from Hudson's Bay. If we come out here, okay, you can see the temperature range, the average warmest maximum temperature, see how things depend on latitude, for example. Okay, so let's go back to Ottawa. Okay, summer days. Okay, so summer days here. A summer day is a day when the temperature rises to at least 25 degrees Celsius. Okay, so you can see the number of days in Ottawa where that temperature is reached, going up almost double. Okay, so if we go to cooling degree days, okay, so the cooling degree days is basically, okay, there's a couple things you can click here, and you can mouse on here, and it tells you, it defines what cooling degree days are. Okay, is one option, or you can go up and have a look here. So it's the number of degrees Celsius a given day's mean temperature is above 18 degrees Celsius. So if the daily mean temperature is 21, the difference is 3 degrees, and it's over a daily average, so it would be 3 degree days, cooling days. Okay, so if this was 25 Celsius, the daily mean temperature, that would be 7 degrees Celsius times day, cooling degree days. Okay, you multiply the temperature difference relative to 18, that you're above 18 to by a day, cooling degree days. Okay, so you can get all, so here, so basically AC, look at the huge rise here in cooling degree days, even to 2021 to 2050 time period, we're getting a 167% increase, and we're getting a 400%, it's 3 times higher, okay, 210 up to 611. Okay, let's go to cold weather days and see what's going on. So you can get very cold days, for example, frost days, icing days, heating degree days, freezing degree days. So the number of freeze-thaw cycles, and what you'll see is, like, let's pick something like frost days. Okay, so over time, we're getting warming. In the 1976 to 2005 period, we had 160 days. Okay, frost days, temperature below 0. Okay, the frost days, again, you can see how it's defined. The coldest temperature of the day is lower than 0 degrees Celsius. So you get frost forming at ground level or on a cold surface, so ice, snow. Okay, and you can see how this is dropping. Okay, icing days, freeze-thaw cycles. Okay, heating degree days. Okay, it's when the temperature gets below 18, how much heat is required. So you can see how you need to multiply those out, like here we go here. Okay, the number of degrees Celsius when the mean temperature is below 18. So if the mean temperature is 12 degrees for a day, so it's 12 degrees Celsius for one day. So the difference to 18 is 6 degrees, so that would be 6 heating degree days. So that gives you an idea as to how much your furnace to heat your house has to work. Okay, so it's basically getting warmer and warmer and warmer over time in different locations. And again, you can select any different location that you want. Okay, this is temperature, so mean temperature, and you can do annual or the different seasons. So winter, December, January, February, for example. You can see in Ottawa the temperature, the winter mean temperature is expected to rise plus 5.2 degrees Celsius by this time period. You know, huge numbers, of course, huge impacts on crops and on people and so on. So the projections are for very large increases of temperature. Okay, so let's have a look. So just play around with this. You can look at precipitation, for example. Heavy precipitation days where you have over 20 millimeters of rain, or if we just do precipitation, we can do annual. You can do it throughout the different seasons. And again, for Ottawa, you can see how much the rainfall is, the annual precipitation is expected to rise, and you can break it down and see how much in the various months and have your plot there. And there's also growing seasons, okay? So the frost-free season, that's the duration of days without freezing, and it's going up from about 155 to, it's going up about 40 days from these two time periods. And if we do the date of the first fall frost, the date of the first fall frost is, okay, so in the fall, you know, it's shifting by 21 days. It's becoming delayed by 21 days, okay, in Ottawa. And the date of the last spring frost, okay, for May 4th, going to April 16. It's moving forward as the planet is warming. Okay, so you have all of this information for all of the different locations, and it's very, very useful information. So wherever you live in Canada, or if you live along the border with Canada, you know, your numbers will be very similar to what the numbers are here. So this is for, you know, Canada, but it'd be nice if there was an agreement with the U.S. and this was extended over all of North America. But you know, it's a very useful website. It's very to find out basically information about where you live. You know, whatever city you live in or your location, you can just get the you know, click on the particular region and you know, different regions, and it gives you all of this data across Canada for that, for all the different regions. Okay, so one of the things we can, you know, we can also look at things like, for example, temperature, mean annual temperature. Okay, so here we are in, go back to Ottawa. Okay, a rise of 4.3 degrees Celsius. Let's come up here. Okay, 5.2 degrees Celsius. Let's go up here, 5.8. Up here. Okay, so you can clearly see that as you go to higher and higher latitudes, the warming accelerates. And I've talked a lot about Arctic temperature amplification. And so that fits right in there. You can see how precipitation or temperature varies. Like, let's look at mean temperatures in the winter, for example. Okay, so look at the winter. Look how much warming there is in the winter. 9.9 degrees Celsius versus, let's have a look in the summer. Only 3 degrees Celsius. Okay, so most of the warming is occurring in the winter as opposed to the summer.